Okay, continuing with our mixed problem review. On this particular video, I'm going to do Charles' Law, and we'll start with number 3 in the Charles' Law. I should have written this earlier. V1 over T1 equals V2 over T2. So in problem number 3, we see that we're solving for T2, and T2 equals V2 T1 over V1, and our initial volume is 50 milliliters, or excuse me, the final volume is 50 milliliters. The initial volume was 140 milliliters, and our initial temperature was 340 Kelvin. Don't forget yet, these always have to be in Kelvin, and Kelvin equals degrees Celsius plus 273. So this answer is 121 Kelvin, but unfortunately we only have one significant digit in this one, so technically speaking the answer would be 100 Kelvin. Okay, on problem number 4, you're solving for T2 again, and so is V2 T1 over V1. V2 is 500 milliliters. The initial volume is 375. And the temperature was at 0 degrees, standard temperature, or 273 Kelvin. And the answer is 364 Kelvin. But as you look at the problem, you see there's one significant digit, so that makes it 400 Kelvin. Okay, for number 7, you're solving for V2 in this particular problem, so it equals V1 times T2 over T1. Volume is 4.5 liters. T2 is 563 Kelvin. V1 is 413 Kelvin. And that answer is 6.1 liters. And number 8, again you're solving V2. So it's going to be V1 times T2 divided by T1. And so your volume is 1.5 times 10 to the third liters. T2 is 303 Kelvin, and T1 is 278 Kelvin, and your answer is 1,630 liters. And yes, 3 significant digits is correct in that particular one. Okay, and then our last one is number 11. And you're solving for V2 again. V1 T2 over T1. And you got 4.40 liters, 298 Kelvin, and 323 Kelvin. And that equals 4.06 liters. I know I kind of flew through this. You can see where the units cancel. I try to keep those over top each other. And you can see with the final answers, again, this is 4.06. So again, hoping this helps. And we'll do the last one in just a second.